Remember the product rule? Up till now, we had the power rule, super easy. And then if you're adding and subtracting, super easy. We learned derivatives of all of our trig functions. Derivative of e to the x, that's the one that stays the same. Derivative of natural log of x being 1 over x. Okay? As much as you can memorize, do. But the power rule, the quotient rule, these are on your formula sheets. And you need to know how to use them. So what it says is, if you have a quotient, and I'm going to use some highlighters here, where you have one function on the top and one function on the bottom. What you do to find the derivative is you keep your bottom function the same and multiply it by the derivative of the top function. Then you subtract and keep your top function the same and multiply it by the derivative of the bottom function. So initially, it's very similar to the product rule. Product rule was keep one the same, derivative of the other one, and then you add, keep the other one the same, derivative of the other one. So we've got sort of that same thing happening on the top, but in the quotient rule, whatever is in your denominator stays in your denominator and also gets squared. So this is Newton's notation with functions. Keep one function the same, derivative of the other one, keep the top function the same, derivative of the bottom one, and then keep the bottom the same. In Leibniz notation, if you had a function u and a function v, again, keep v the same, and then the derivative of the top one would be du dx. Right? That's notation for derivative. And then we keep the top one the same and multiply by the derivative of the bottom function. And finally, you keep your bottom function and square it in your denominator. This is on your formula sheet, so once you realize I would like to solve a question using the quotient rule, it's actually not very hard, just long-winded. So there is, in words, what you have to do. The denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, all divided by the square of the denominator. Wow. Right? But it's not actually that bad. But if you memorize that and someone asks you what's something you do in calculus and you repeat that to them, yeah, you're going to lose them right away. So what does it mean? Find, okay, this notation, d dx means the derivative of what's in the brackets. So find the derivative of what's in the brackets, and we can do this all at once. If you want to do some work off to the side, you know, using your formula sheet, you can say, well, my top function is x cubed, so the derivative of that would be 3x squared. My bottom function, that would be v, would be 3x minus 7. Its derivative would be 3. If you want to show that work off to the side, you can. Most people go directly to writing out the answer and just say dy dx equals. Do you want me to color code again? Okay, I'll color code. So what did I do? I highlighted my numerator in yellow, my denominators in green. So we kept the denominator the same. Kept the bottom the same, multiplied by the derivative of the top. Then, there we kept the top the same, multiplied by the derivative of the bottom, all divided by whatever was on the bottom gets squared. And 99% of the time, well, it might be 97% of the time, you can just leave your answer unsimplified, just like that. That's perfect. But sometimes, and especially in textbooks, textbooks will always simplify your question if you were looking in the answer key. So what would a simplified version look like? well, if I multiplied out the tops, this is what I would get. And in fact, sometimes in a simplified version in a textbook, they would actually say, hey, can you factor the top at all now that you've simplified it? Yes, I could take out a 3 and an x squared. That would leave me with 2x minus 7, which would be good to check because it might simplify with what's on the bottom, but it doesn't. So this would be a very typical way that a final answer would show up in an answer key. Okay? How does the IB like to get you to do this? They make it a show that question. They say, show that the derivative of blah, blah, blah is equal to 3x squared bracket 2x minus 7 all over 3x minus 7 squared. And so because you have to show that, you do have to simplify it. It's not just enough to do the derivative. Yeah. So that's your quotient rule. Try a couple on your own. And here's the example for number 3. Or the answer, sorry. Again, no need to simplify. And so once again, calculus, well, it kind of almost takes you back to, you haven't done questions like this since grade 9. And what I mean is, in grade 9, they had questions that were like, solve for x, and it was like 3x equals 9. And you could just figure out the answer in one step. It seems like once you got to grade 10 pre-calculus, now you have to show work for everything. And there's like lots of work to be shown, or multiple steps to show. And now we get to calculus, and we can do something in one step again and be done, which kind of feels a little bit strange. And yet, if the person doesn't know calculus, what you just write down looks terribly confusing and complicated. But it's not that bad. How do we do a quotient rule? Well, we keep our denominator the same. Multiply by the derivative of the top. Subtract, keep the numerator the same, and multiply by the derivative of your denominator over your entire denominator squared. Now we can apply questions that we've done already, so this is a little bit of a nice review. We remember that our derivative finds every single tangent at any point you want. So if we find the derivative of this and we plug in x equals -1, then we're going to find the slope of the tangent at that point. That's what this question is asking. Find the slope of the tangent at x equals -1. So we find our derivative using our quotient rule. Keep the denominator the same, derivative of your numerator. Subtract, keep your numerator the same, derivative of your denominator over your denominator squared. Then to find the slope at -1, okay, if you plug in -1 into your derivative, you find the slope. If you plug in -1 into your original function, you will just find a point on your original function. So I'm going to plug -1, oh, here's some simplification. Might, in this sense, make sense to simplify it first. But then you can plug in -1 in for x. And it simplifies nicely to be 1. So what's another review question that this same question could have asked? Instead of saying find the gradient of the tangent, it might have said find the equation of the tangent. So if you want to find an equation of a line, you need the slope and a point. So we just figured out the slope part. If you wanted to find a point, you'd have to plug in -1 into the original function to get a point as well, and then you could use y equals mx plus b or the point slope form to find the equation. Okay, 5 and 6. Again, I'm going to let you try it first. You might have to scroll back in your notes because you've forgotten some derivatives or you haven't memorized them yet. There's the first one. Now I'd recommend today during lunch, if you had to look up any of these, did you have to look up tan that the derivative was secant squared? Did you have to look up natural log that the derivative was 1 over x? Minimum, take 2 minutes at lunch and choose one function that you didn't know the derivative of and make sure you memorize it. It'll save you tons of time. This whole next 3 units we do derivatives. If you know right away that the derivative of tan is secant squared, instead of having to flip through your notes or find it, it's going to save you a lot of time. If you know that the derivative of natural log is 1 over x, it's going to save you a bunch of time. So if you have 2 minutes at lunch today, memorize one of them. If you have 10 minutes at lunch today, try to memorize all the special ones. Sine, cos, tan, 1 over x, not 1 over x, sorry, natural log of x, and e to the x. There's 5 of them. 2 minutes each, that takes 10 minutes. So that you don't have to look them up every time. Okay? Here we have a show that question. So we start by doing our quotient rule and writing it out without it simplified. This is a G without the little loopy. It's kind of Q-ish. There we go. And so there's our derivative without it being simplified. Now we have to start simplifying things. So the x squared times 1 over x would just be x. Generally, we would write natural log of x times 2x. We'd write the 2x in front just because it makes it clear. I might even put this in brackets because you don't want to get confused that the 2x is also inside of your logarithm. And in a show that question, right, all the way through, you have to remember in a show that question that what they're really doing is telling you and giving you a hint. That's what it's supposed to look like in the end. So at this stage, after I've simplified it at first, I'm like, I've got an x to the 4. It has an x to the 3. I need an x to cancel out. What can I do? Well, maybe I could factor out an x out of my numerator so that 1 could cancel out. And sure enough, once it cancels out, you're all happy. Super good day. What better way to start the new year than with a show that question with derivatives? All right, so we have a couple more questions that we're going to quickly do. Oops, did I skip one? I did skip one, didn't I? Okay. I'll just do that one together with you. Let's see if I have it. I don't know why it's missing in there. Oh, I guess I'm missing it on both. I will just add it in. So, we've got f of x is 3x squared over 5x minus 1. Write down the vertical equation of the vertical asymptote. Vertical asymptotes on a graph happen when you have a non-permissible value. Can you see in this question that your non-permissible value, x can't equal 1/5, because then you would divide by 0. That's a non-permissible value. When you write a non-permissible value, you can have the line through that equal sign because you're saying x can't equal 1/5. When you want to find your vertical asymptote is an equation. It's going to be x equals 1/5. So that's part A. Part B says find f prime of x. Okay, so we're going to start off. Keep your denominator the same. Derivative of your numerator, keep your numerator the same. Derivative of your denominator over your denominator squared. And then the question says, can you write this in this form? Well, here they're saying another way to simplify the equation. Because right now, my denominator matches up, so I know that that's right. What do I need to do? I'm just going to need to simplify my numerator. So in this case, I'm going to distribute the 6x, which gives me 30x squared minus 6x, and multiply these together, minus 15x squared. $30x squared minus 15x squared gives me 15x squared minus 6x. So now I've written it in this form. It didn't ask to say that A was 15 and B was equal to negative 6, but you can see that now from your answer. So there's 2 review questions for you just to look at the bottom. See if you remember how to do them. I'll show you the answers for those in a second. If you were stuck on the first one, before you do the derivative, sometimes you get tempted to do the derivative too quickly. Actually multiply it out. And then the derivative is easier. Although this question has some good foreshadowing for what's coming up. Because you might say to yourself, oh, but Mr. JR, what happens if it was that? I wouldn't want to first multiply it out. I mean, I guess I could using my binomial theorem and get 8 terms. But isn't there an easier way? Yes. But we don't know it yet. That's the foreshadowing. Anyways, then the derivative is easy. Okay? Notice the notation in the question said find ds dt, so our notation in our answer should look that way. So in this case, we wouldn't use s prime of t for our notation. We would use the ds dt. Find dAdr. Well, there's a derivative of that equation. And then when r is 3, just have to plug it in and get 6 pi. Did anybody recognize this formula? What's that formula for? Area of a circle. Nice. Very cool. And then the derivative is the circumference. Whoa. Anybody know what the volume of a sphere formula is? You've probably forgotten that one. Okay. Sorry, this question just got me all excited about math. So the fact that the area of a circle, the derivative is the circumference. Check out the volume of a sphere. The derivative of the volume of a sphere. You bring the 3 out in front, which would just become 4 pi r squared. That formula is the surface area of a sphere. Some crazy math stuff going on. Crazy math stuff going on.